Ei kato, laavaa. Kato. Siellä se striimaa. Striimaa kaikki. Mennään etuun. Tohon.
This is the best minister of the world. Like science and those are one.
I have no idea. Yeah, we were. I like it better than the one from last. Like number 9, there's like 108. 8 or 9, I have to decide.
I can like give you some signals.
But here's some thought. You can start to compare some. We have one Linux and we are trying to transfer his presentation to our Mac. So feel free to entertain the key.
All my jokes are Linux related, so I think that's an appropriate.
Hello, everybody. Please, can I have your attention, please? They are having some technical Linux problems there, and we are trying to help. So I'm going to tell some Linux jokes while we are waiting. And you can say to them that compile the kernel or any Linux joke that you have. Now's the time.
Have we tried turning it off and on again?
Yes, and we compiled the kernel and everything is running fine. But anyways, so I am...
Question, could we get the monitor to the screen so we can help fix the problem?
Yeah, that would probably help. Everyone would have like great suggestions what flags to use for the processor.
We can do it like Twitch TV. Each row is one letter on the keyboard, and then you vote which letter you press.
Install Gentoo.
Did you manage it?
Not quite.
Okay.
Most of the presentation.
Okay. Can you hear me in the back if I speak without microphone? Okay, great. So I am Pekkis from our most generous and wonderful sponsor, Fractio, and also one of our first speakers. So here is my colleague, Ville.
Hi.
And we are going to talk about designer and developer collaboration. So I'm a one of you is a developer rather than a designer. Okay, so you know how it is to work with those guys. I broke his arm, like you can see. So it happened today when we were having an argument.
That might happen, yeah.
Yeah, it often happens, you know what it is like. They always just drink their lattes and cups of fine coffee while I'm trying to code.
And fix Linux problems. Yeah.
So, yeah.
Maybe we should just go ahead and start the presentation. Yeah.
Yes, I'm going to like stay here very far from you.
So we've been doing a lot of projects together, and I think this is kind of like a short-term history review for us as well, like how we've been working together and finding the right tools to make the best out of it.
Yeah.
So, well, this is kind of default that we have two roles as like two persons, and we think there's a lot of problems related to this. And of course, nowadays it's not that much about like separate roles anymore, and that's what we're here to discuss today. And well, you know, this is the thing. We have design, we have sketch files, we have Photoshop. I don't know who uses that anymore, but anyway, we have something, some visual representation or an idea, and then we have the other part, which is kind of like making the thing live and, well,
Yeah.
just your part, basically.
Yes, I always like, probably everybody of you, every one of you knows that we get something from those latte guys. It's something, and then we get it and we do our best, and they say that it's not good, and even though it is, but they don't like our CSS or anything. They always, it's not, my pixels are never round enough.
And our demands are always too much. Right?
Yes, they are not rational. They are like terrible.
And I think the basic reason for that these, why I have broken arm and all that, is that the problem is here. And I think the handoff is always the main issue, because there's always a lack of information, how you share stuff. You might have sketch files, you export pictures or whatever, and then there's always something, idea in the designer's head or something that should be shifted to the developers, but it just doesn't, because it's not like magic.
Yes. Can you, like, when you are developers, you know what we are talking about. Tell some examples of what is handoff to us. For example, in like, what was it like in 1990s? What did we get? Or early 2000s? Some examples. What do the designers give us?
PSD.
A meeting.
Yeah. PSD, what is that? Photoshop image, yes, that's at least very familiar to me. They give me the Photoshop, and then I said that I have Linux, I don't even have Photoshop, just give me the PNG, and they deliver it, and somehow I have to like know how everything works from that one image.
And the developers are then asking for what is this color, or they might pick one from their own library of colors or whatever, and then the problem starts to kind of like escalate because of
Yes.
like
What else?
misinformation.
Any ideas?
Image optimization.
Image optimization.
Yeah, wrong kinds of images.
Yeah, they send like, yeah, that they can do, yeah. But we are thinking maybe in some grander lines or grander strategies.
Missing the stateful thinking, like a button with just one look, no other states.
Yeah, that's a problem, of course, with all these, like, for example, the Photoshop image, that I can't know what happens when I click something, and then I have to go ask, and there's no idea.
Or you might have a PSD which has like the normal state and an active state, hover and all that, but then the designer has to spend time to kind of like write down this is this and this is that, and then still there's something missing, and then the developers go nuts. And just,
Yeah.
so it's a problem.
Maybe should we?
Yeah, and well, this is just a bunch of like stuff that we came up quickly to kind of like show the idea that we get the PSD files or whatever images which are static, or we might have a bit broader sense, a style guide which has colors as like RGB values and maybe fonts and something like that, or even a dummy HTML file to kind of like point out that this is how it should work. Maybe it might be even clickable, but it's still lacking. There's the thing that I had this idea, and then I have this thing, and I throw the ball to you, and you can like look at the ball and think yourself.
Yeah. And what I have been like asking for years is that why can't I get this stuff like already working? Why is there this intermediate step where I got like pretty much of the stuff that I want to have, and then I have to like implement some style guide or just refactor some dummy HTML, and it's stupid. And even though I don't like to admit it, I think that even those guys have a little bit reason in them, and they think that it's stupid.
And hence this is bullshit. And of course, after this has become like more applications like Zeppelin and Avocode and such things that are more in between developer and designer, offering still the same stuff that are in style guides, but maybe including like CSS code made from the components that are only in the sketch file, or something similar, or even like more detailed margins and all that. But I think this is still not enough, because it's still a handoff.
Yeah, it's better. I think that when I can go to Zeppelin myself and just like copy paste the color or something like that, check the margin widths, pixels and stuff like that, it's an improvement, but still it's not where we would like to be.
Because it's still a handoff. And handoff means that there's always the chance for someone to understand stuff like not wrongly, but a different way. And this is what we want. Of course, everybody knows that the heart should be maybe a unicorn in some places, but like we don't think that there should be one guy doing both. We think that there should be place for both to kind of like coexist and do their stuff, but in the same place, to see like the same stuff that they're doing together.
Yeah, and the idea behind this is that we've been thinking about this a lot, and we've come to the conclusion that our tasks are like converging. More and more they are converging and overlapping. It doesn't mean that Ville must know about Kubernetes cluster or Dockers or anything like that, but even still there's lots of like common ground for developers and designers, and I think that Mr. Tarvainen, who is here somewhere, I can't see because of the bright light, he was talking about this designer role.
Yeah, which is the unicorn basically.
Yeah, so...
But I think it's a bad way to go, because nobody can be that perfect to kind of like nail down everything.
Of course, but as a concept, that it's a bit of something that we should be able to do.
Yeah.
So, yeah.
And well, it's not a unicorn solution or a holy grail, but this is what we've been trying for a couple of months maybe now. And it's at least the right direction, I would say.
Yeah. Who of you has heard of this storybook? Okay, pretty many. Who has used it? Okay, so...
More questions. Who has used it with the designer? One.
Wow. So you're on the same page. Two. Wow. Okay. So here is where we
we switch.
We're going to hug each other. So
you can show your perfect design.
Yes, I can, but I'm going to explain Storybook.
Yeah,
first.
do that.
So those of you who don't know, Storybook is this like when we go to the component-based thinking, we use either I think that it's only for React, but hey, who wants to use something else anyways? But yeah, because we are using React in many of our projects. So this is like a playground for your React components, and you can develop them in isolation of the actual software. So instead of like helping Ville to put up his Dockers, and you go into a particular state in your program, you can just like code your components here in isolation. So it's pretty fantastic. I've been doing it in my private projects, and I think that I code maybe 50 or 60% of my components here because it's so much easier. So I really like it. It's free, and it took me like, for the first time that I did it, it took me like maybe 1 hour or 1.5 hours to like make it work. So it wasn't such a big deal. So let's see first our application. Is it running? So here is my hardcore application. Here's
Designed by Beckis.
Yes, of course. So here just it is a list of 2 lists of persons. The female persons are pink and males are like baby blue. And yeah, there's young people under 40 and old people over 40. So basically there's a REST API and blah blah blah. I can of course, because this is a simple example, I could code it here and nobody would notice. But anyways, even to make this run, I have to have an API that returns stuff to me. And Ville can't cope with that. He really can't run a node process. It's too hard for him.
Or I can actually, but it's always like out of the time for me to do something more productive.
Yeah, and for me even. So in Storybook, I can just like, do you have Atom here by the way?
Yes, it's open and it's the...
Okay.
Process.
So basically what I have to do with Storybook is to like describe my components functionality with these things called stories. So I have to like, of course 99% of my components are just stupid. They only have props. So I don't have any internal state even to manage here, just the props. So if we think of our list, there's this avatar, which is just this picture, and then there's this person, which is like, well, here is male person, Ville Mikko, here he is male, and then there's his sister Wilhelmina Mikko. Yes. So you can see that I just like describe these. It's so dark that I can't really see.
Always have to teach things.
Yes. So, like you can see, if the font is large enough, you can see that my stories coexist with the components. I don't care about your particular project structure, but anyways, they co-locate with the components always. So it's pretty easy to find them and describe my stuff. For example, for this avatar, there's really not much. I just random generate some image with Faker, and then I say that basic.
Larger font.
Oh. He can't use his own Mac. So I just say that these are stories of Avatar, and I only have one story because there's not much to the Avatar. But for example, person. So I just generate my data here, that I have this mail that has my data and randomly generate avatars and IDs and stuff, just the data that my person component needs, and then I describe both the mail, so I give it the mail and some fake action that I can show you where it shows. So I describe my 2 types of persons, and then I can just view them here. And of course it hot reloads, so I can change these pretty quickly if I decide that here is Atom, my style is bad. I want my mails to be a different color. Of course the hot reloading will fail now when I save this. No, it doesn't. So it's pretty easy, pretty quick to iterate these, and when I'm interested in this component, so it's nice. And of course I can compose it, the bigger components out of my smaller ones, so I can, here is just a random person's list. And if I want to go I can like go to the full even page components if I want to. I wouldn't go there because then I have to like be interested in where my state is coming from. I might have Redux or something there. So I would like keep it in just the purely reusable components. So no pages. But I really don't have a good opinion on that yet, where to stop and where to not to do it. But anyways, can you tell a little bit about our work when we work together?
Yeah. What this is for a designer then is that, of course, I don't want to fight with like the React components, and I might not know how to do them and make it work, so to say. But usually we just sit next to each other on a carpet at our office or something, and basically Beckis is doing a component and making a first story to the storybook, and I start working on the CSS and other stories like for a button, the hover state, and such things mentioned before. And I can just do that all the time. And when I see that, okay, this component actually needs these features, then I can just like poke him that, hey, I actually need this stuff. And then he's making it, and then I can like update it at the same time, and it's very flexible.
Yeah, and of course, when I need new styling, I have this mega super state for my button, and then I can either, most of the time I can do it myself, of course. But if I can't or I won't, I have some coding to do, I can just ask Ville like to do it. And our common single state of our work is in GitHub. So we just like, it hasn't like slowed us down, I think. No, it just, it's something that we have to like live with, that we have to commit and then we have to pull. Yeah.
So I think it's even a good thing that you can like review the stuff that you're pushing and pulling all the time.
And I think that even the designers, they like get used to single React structures like generating those class names or maps and stuff like that. It's not that hard. It's not any harder than like a template engine. It's easier, I think. What do you think?
I agree. And this is the thing about the circles that are overlapping, that we actually have some place where we can freely do, like he can do the design stuff, like CSS, I wouldn't maybe count on it, but, and I can do maybe some basic React and learn on the go, and that's just a very good thing.
Yeah. I don't think that it's perfect, of course, because this is like the first generation, but I did a comparison with all the similar tools, and I thought that this was like the most professional, and I really liked it. And whoops.
What other tools did you try?
I tried what was Carte Blanche, which is a similar tool like this. They presented it at what was the name of the React Festival in Paris on the spring. I don't remember, was it ReactConf or something? But anyways, they did the presentation with it from there, but the development was stalled completely. No new commits like in months when I last looked. And then I looked at this Structor thing that's developed by a startup in Estonia. And then there was this one that whose name escapes my mind at the moment, but I think that I reviewed 3 or at least looked at 3-4 alternatives, but this was the most sane one. It had comments.
And now there's already some stuff built on top of this. I don't remember the names, but like there was some new features like how you could comment different sections. And all that. So it's interesting to see where it goes.
Yeah, and that's actually true. I forgot to say it, but this also has been like minimizing the need for like tests, because you kind of test these things here because you have to click through all the states, and when your components are simple, it makes me question whether any like unit tests are even needed, because this kind of handles it. And it also functions as a style guide, of course, because only the difference being that this works. It's actual production code. So, yeah, I think that there's all kinds of nice directions that you can go from here.
How much time do we have left? I was just
I have
thinking,
no idea.
Maybe time for questions?
Yeah, some people even ask questions, so feel free.
Yeah.
This tool of course looks really nice, but have you solved or have you had a problem with, from design point of view, how to see the general picture or the overall context, because this tool shows all the components kind of separately. So do you kind of feel the need for the overall picture of design?
We are still using Zeppelin, for example. So I think that's a good point, that this really is not like the silver bullet that only uses Storybook and that's it. It's just the one tool in our toolbox, and I think that's the good way to think of it. And so still, like, Zeppelin is one way, and of course we have the meetings, someone said, that we go through stuff, and so yeah.
Yeah, and one thing that I have noticed is that I tend to pretty easily actually lose track of the grand picture, and begin to switch 5 pixels to 4 and really concentrate on the small things because it's so easy here. So you can spend countless of hours of tweaking your little components and never getting to the big one. So yeah, that's something to consider, surely.
More questions?
Well, yeah, about those unit tests, like you said, that this replaces your unit test basically. If you have 100 stories and you make one change, are you going to click through all those stories and see how it affects to your thing if you don't do unit tests?
I was thinking about some, what would be natural would of course be to automate maybe this clicking and maybe do it here and then use some visual recognition or something. I don't know, but basically when I only have components that have props and my state lives in some sane place, I've noticed a general lessening of the need for tests anyways. So this is just one part of that equation. I of course have no answer for the question what should you test and how much. So, but I just been noticing that I've been needing less tests to make stuff reliable lately in the last few years.
But that's probably not this tool, is probably because we are getting further about this function programming and stuff in general.
Yeah.
There was a question, yeah.
Yeah, so we have been using various plugins for Sketch for exporting HTML mockups, and that has helped a lot. It of course doesn't solve the state problem, but it solves it already. You don't have to open Sketch all the time to look at the margins. So that's something to look into if you want to kind of narrow the gap between the developer and the designer.
That is actually what Zeppelin, for example, is doing.
Yeah. So the question was that you can also use Zeppelin plugins and stuff like that. Yes, sure you can.
Sketch.
Yes,
yeah.
Sketch plugins and stuff. Yes, this is our solution kind of to the same problem. We decided not to go there. We decided that for our developers who can write HTML and simple React stuff and those things, this is a better way, I think.
Yeah, it's kind of we use Zeppelin, for example, to get the dimensions and all that, and there is a web view for that, and we export the Sketch files there, so it's a plugin for Sketch. But what is the problem with that? That there is still the handoff, that someone is always looking at it, and someone has to implement it because it's not working stuff. It's really like a dummy HTML.
Yeah, I think that works because you probably mainly work with the same designer, but I see a lot of problems if you work with 10 different designers over 10 different projects. It's going to be really hard to actually put this to good use.
Yeah.
Might be.
Sure thing.
That's something for the future. I think that we have no idea where this is going, but this is the best that we've come up with so far. I have no doubt that it's gonna stop here.
Where would you go from here? Because like this shortens the feedback loop. So you don't have to talk to a developer, and you can do a lot of the stuff yourself, which is much faster than what we did before. But still, it's very different from, for example, Sketch, where you just drag a line and you actually see the line changing, right? I think it's a huge feedback loop, especially for a designer, because the designer really wants to get rapid feedback from every change. Otherwise, things become too abstract and ideas die in your head, right?
Yeah.
So if you wanted to, like, say maybe 2 years from now, a new software comes in that makes this workflow much better, how would that look like?
So the question was that how to make this better and what's the next step. So in my opinion, I think the solution or the next step would be to kind of like make some sort of plugin or something to Sketch that you created stuff, because of course it's much faster for designers there, like you said, but still, like, you might get CSS from Sketch and then you copy paste it to the component and such, but it would be much better if you could like export React components from Sketch, some like very rudimental. And we actually have one company who's doing this kind of application.
React Studio or something like
React Studio
that.
is the Neonto is the company who's working on this issue actually.
Neonto?
Neonto.
Yeah, we can like share that later. But yeah, from my perspective, if one could make a graphical user interface on top of this, and it would generate the code that I would generate, and generate whatever of those 1,000 ways of this year to make your CSS in CSS modules or BEM or any of those 1 million terrible JavaScript libraries to generate your code, then it would be like perfect. But I doubt that it will happen. The Neonto software didn't offer anything for me. It had absolutely nothing on me.
But they have good intentions.
Yes, and that's why we try to coach them like what we would want to have.
Yep.
All right, guys.
Okay.
One more question.
Oh, one more.
Yeah. So even the designer has a wife, a client. I would see how do you export this to somebody who actually makes the decision. I think that would be ideal that you could export this and then send it for approval also to non-developer or designer.
Yeah, one of the I don't remember the team, but who's building on top of Storybook has already made a feature for it that you can basically copy paste the link for someone in Slack or something that look at this component and how it looks. So maybe that's at least towards that.
But I really don't understand. I don't know if they understand an exported storybook that can be done. If they would understand it any better than they would understand a style guide. I think that like the Photoshop image still has its uses for clients and those kinds of people.
Okay, thanks.
Okay. So our next speaker is Jussi Rytkönen. Please welcome.
I'm not sure. Can anyone hear me or should is that
And thank you for the previous speakers. As a quite design-oriented developer, I can strongly agree that we need more love between the intersection of designers and developers. And this talk will dwell into a bit more technical stuff. So hopefully, quite a lot of you, I guess, were developers. So, oh fuck. Yep, that was perfect. I have a guess, and if it's not gonna work, then I think we're gonna switch to the next speaker. Yes, indeed, we had some technical problems. I was supposed to do this on my computer, but since I'm not, this is looking really bad. Okay, I need to think.
Who's our third speaker? You're welcome.
It's up.
Yeah, okay. Let's do, it's probably safer. I'll try to get this fixed in the meantime, and then we can come back.
No pressure.
Lock the doors so you can't see.
Right, okay. So I'm going to talk about compositional data manipulation using lenses. And this is my first time here, so just a few words about me. My name is Vesa Karvonen. I'm a senior programmer at...
Can't hear you.
You can't hear me?
Could you use
Take the mic.
Okay. How does this work?
Sitten korvan taakse se toinen. Tulee niinku sanko.
Onko näin?
Joo.
Okay, can everyone hear me now?
Yes. Yep.
Okay, cool. So I'm going to talk about compositional data manipulation using lenses. And this is my first time here, so a few words. My name is Vesa Karvonen. I'm a senior programmer at Reactor, and I've been programming for a very long time, over 25 years. I actually started programming, well, actually the first programs I wrote was with a VIC-20 home computer in BASIC, and that was over 25 years ago, well over. But I really started programming on Atari ST at about 1990. And I've used a lot of different kinds of programming languages and different programming paradigms and multiple platforms. And actually, I haven't been programming in JavaScript for a very long time. So, how many of you have actually used lenses or know about them? So some have actually been using them. Cool. But for most people here, lenses are a new concept. So what are lenses? A lens is essentially a bidirectional program that can be run forwards to update and backwards to extract an element from a data structure. So let's make this concrete. We have these operations, an operation to update an element, and this is actually the lens here. The lens is a property lens for the property X. And this is the data structure that we are manipulating. And this is the value that we are putting into the data structure. And if you modify the value, then we can see that the result changes. So the answer to everything is 42. And actually, the more fundamental operation is the modify operation, which gets to see the value extracted from the data structure before computing the new value for the element. So we have the x equals 1, and then we can modify it, and we can add 1 to it, or we could add 41. So we get the answer to everything. And of course, we can just use lenses in the backward direction to get data from a data structure. So once again, we can get the answer to everything. So that's basically what lenses can do. They can be run forward to update data structures, and they can be run backward to extract information from data structures. But really, the reason why you should be using lenses, if at all, is that you actually have a data structure that is a little bit more complex than just a simple object or an array. And what you need to do is that you need to update parts of that data structure, and usually you need to make it so that the shape of the data structure remains the same. You just zoom into some element of the data structure and then manipulate it in some way, and then you have to put back a new data structure that has the same shape and also retains original data in the data structure. So if that's the case, then lenses can probably help you. So we are actually using my library here, partial lenses. It's embedded in these slides, and it actually provides more than just lenses. It's an optics library. So what are those optics? So there are, first of all, traversals, and traversals are optics that can focus on multiple elements of the data structure. So for instance, if you have a data structure which has an array of elements, then the traversal could target every element in that array, and could also zoom into elements of those elements in the array. Lenses, on the other hand, always operate on one element. They have one focus. And isomorphisms are a restriction of lenses that are invertible and always focus on the whole data structure. There are also other optics concepts, but in my library, those are the concepts implemented. And the reason there are actually good reasons why we are not why my library isn't implementing any other concepts is that because of the dynamic typing nature of JavaScript and the fact that these are partial lenses, then we can actually sort of subsume quite a few other optics concepts into just those three. So the reason why the update direction is the forward direction for lenses, and this is sort of the only theory part that I'm going to talk about, is that optics are really just mapping functions. So here's like a general mapping function. Everyone knows Haskell here, so this is like a very simple Haskell mapping function. So we could instantiate that to a type like this. So this is the ordinary list mapping function. It takes an operation to map a value of type A to a value of type B, and then it takes a list of values of type A, and then it returns a list of values of type B. And that's really close to what optics are, except that because we want to also extract elements, then we cannot just always update the whole data structure like with a mapping function. So we actually have some sort of lifted representation for the operation that we want to perform. So this is like the same template for a mapping function, but instead of returning a value directly, the lens or optic actually returns an operation that returns a value. And then we can run that, we can substitute different operations. We can substitute an operation to get elements from the data structure, or an operation to update elements in the data structure. And that's how lenses can perform different kinds of tasks. So when we compose such mapping functions, and we can compose those, then that's sort of the forward direction of composition. So we have a list mapping function, and then we have a function that maps the first element of a pair, and we can compose the list mapping function and the function to map over the first element of a pair. So we get a function that manipulates the first elements of tuples or pairs in a list. And down composed the other way, we have a function that takes a pair, and the first element of the pair is a list, which we are not then manipulating. We can compose those particular functions in both ways because they're polymorphic. And the nice thing about lenses is that when they adhere to certain laws, then we can compose them quite nicely. So here's actually, we're not going to get into details here because of time, but these are sort of the basic laws under which lenses operate. So that if we get something from a data structure and then put it back, then we get the data structure that we had originally. And then also in the other direction, if we set something to a data structure and then we get that same element, then we get back what we set there. So what is composable? I think there's a lot of opinions on what is composable, and I see a lot of people talk about their approaches to programming or their particular libraries as composable. But are they really composable? In my opinion, to be composable, you should have essentially some sort of composition operator. So for a monoid, you have a plus operation that takes two elements and then returns another element of the same type. And then there's also for the monoid there's a zero element, and we have these laws that if you compute the sum of any element and zero, then you get the other element back, and so on. Of course, monoid is just an example, but the point is that if you want to claim that something you've written is composable, then you should have some sort of laws, some sort of composition operator to actually make it explicit that you have something that can be composed. If you just have a bunch of functions and you can glue them together in some way, then that's not composable, in my opinion. So the ways in which lenses can be composed are many. One of those is that they can be nested, and that's actually a monoid. Of course, lenses can also be recursive, and that's a fixed point of nesting. We can write lenses that adapt to the data that they're manipulating by examining the data while they are zooming into the data structure. And that can be explained as a semi-group. Then we can also choose in another way. This is like an extension of the adapting behavior, where we can choose elements and completely skip parts of the data structure if we are not interested in them. And then we can also fully query data structures. This is like a very limited use case of lenses where we don't actually get the full backwards and forwards directions from a lens. But here's an example. So let's see how we can compose lenses. We have here a data structure. Yes. And we have here a data structure, which is an object that has contents, and inside that contents there's an array of objects which have a language and a text. And what we'd like to do is that we would like to extract texts from that data structure in a particular language, but that's the first thing we want to do. So here we have the beginnings of the lens that we want to compose, and first of all we take take a parameter, we can of course write functions that create lenses. So that's what we're doing here. And then we have the call here to get the text in the desired language from the sample text. But of course, we are only at the beginning, so what we get is actually the whole data structure here. So let's fix that. Let's start by zooming into the contents. So now we actually get only the contents part, which is the array. And then what we then want to do is we want to find from the array one object where the language matches the language that we are looking for. So now we have the object that has the desired language, English. And then finally we can extract the actual text. So now we have the title of the text. So now that we have this lens, we can also manipulate it, manipulate the data structure from that. So we want to write another value there, then we can just substitute the new title into the data structure, and we get the whole new data structure out of the lens. And one thing it's important to realize here that lenses don't mutate the data structure. They just create a new data structure with the modified data or the updated data. Okay, one of the nice things about partial lenses is that we can also not just update existing elements, we can also insert new elements. So let's create, or actually let's try to insert something in Finnish. So you can probably see that otsikko there. I'm gonna remove one of those texts. Right. So now we have the new otsikko there, but then the problem is that it doesn't adhere to the same data structure. So how do we fix that? We can make it so that we default some parts of the data structure while we're zooming into it. So now we give a default for the object that we are manipulating. So now we get the language text there, and then we can also remove elements using partial lenses. So given that I'm gonna put back that English text there. I'm not going to change the title, but let's remove the text in English. So now we have the whole data structure, and then we just remove the English text. If you try to remove something that isn't there, then nothing happens. But if we remove a text in some particular language, then it just vanishes from the data structure. And the reason why that happens is that this default lens works in both directions. When we are viewing through the lens, it gives the default structure, and then if we actually write back the same default structure, then it actually removes the whole element. And let's then talk a little bit about traversals. So what we have here is a lens which can manipulate a single element. So let's make a traversal which can manipulate multiple elements. So I'm going to So now we have the beginnings of the traversal, and we zoom into the contents, and then what we say is that we want to manipulate that part, the contents, as a sequence of elements, and then we can zoom inside that sequence into the text. So we get all the titles. And then we can also manipulate the elements through a traversal. So let's say we want to uppercase all the elements or the text. So now we have all the text in uppercase. And we can do all sorts of other things also. We can fold over those elements and so on. But we have to move on. So I hope you got some sort of sense of what you can do with lenses. Basically, you can zoom into data structures. You can create lenses that maintain the data structure, and then you can perform quite complex manipulations of the data. So what does it mean that these lenses are partial? If the view, if you're trying to zoom into an element that doesn't exist, then the view is undefined. And also, if you set something to undefined, then it actually removes the element. And the reason why undefined is used for that purpose is basically because it's a value that is not normally a valid part of any data structure, any real data structure, like JSON, for instance. So we can use that as a sort of nothing element. Also, in partial lenses, the idea is that if you have a type mismatch, so you're trying to manipulate an object as an array, or vice versa, or maybe you would like to manipulate an integer as a string, and so on. And then the idea is that in that case too, you should also make the lens such that the view will be undefined. And also, if you set through a lens an element that has sort of the unexpected type, then you can change the type. So let's examine. So here's in fact an example where we have a type mismatch. We are trying to get the 0th element of an array, but of course what we have here is an object, so we get undefined. But if we change this to an array, then we get the first element. Also, if we do the converse, we try to get a property x, then we also get undefined. And then, but of course, if we have a proper object, then we get the value. And this also works in the other direction. So if we have an object and we try to manipulate it as an array, then we actually just get an array. And of course, these things compose. So let's say we assume that the data structure is a nested array, and this also works out. So time is running short. So what are the applications of lenses? So of course the basic application is data manipulation, like we've already seen. My original application actually was a sort of data binding on the client side by combining lenses with observables. And what you get as a result is a sort of reactive variables. You can set up a variable, a root variable that contains a blob of data, and then you can create variables using lenses that are derived from that blob. And they can view the insides of that blob, and they can also modify the insides of the same blob. And you get a very powerful form of data binding. If you compare it to many traditional data binding frameworks like Angular or MobX or Reagent or Knockout.js, then this can be more flexible thanks to the possibility of using lenses that can transform the data structure and adapt it to your needs into the needs of the components that want to use the data. And that's not directly possible necessarily in those frameworks. So what you get is this sort of way to write user interface components by transmitting data to these atoms, or the reactive variables, to controls, and then transmitting data using lenses to other controls, sub-controls. You get kind of fractal architecture. And the idea is that you have application state, which is something that you necessarily cannot always completely design by yourself. You get some data from some service outside of your control, and you have to be able to plug your components directly into that state. So what you do is that you can then manipulate the data into the form that you want using lenses, decompose data. and also you can compose user interface components. That was the original application. So basically, the library provides a very comprehensive API. So it has, can you see that? So it has a fairly comprehensive API for manipulating JSON. You have all those nesting and query and recursing and debugging, and then you have traversals, lenses, and then also isomorphisms. And for manipulating ordinary JSON data, you can manipulate arrays in various ways, and you can manipulate objects in various ways. And basically, you get a fairly comprehensive set of operations for manipulating ordinary JSON data. And of course, you can also introduce new isomorphisms, lenses, and traversals. There are actually combinators that make it very easy. And in fact, you can do that without having to know about stuff like category theory. So inside the implementation, there's actually basically a so-called static land specification compatible implementation using functors and applicatives. But that's not actually exposed currently. You can use pretty much all the features of the library just by using the combinators, and you don't have to know about those internal details at all. And it's also quite performant. I've recently spent a lot of time optimizing it, and it's now actually about as fast as you can get with Lambda, for instance, sometimes faster. And I have some future plans. For instance, one of the features not currently implemented is the, to be able to do so-called indexed traversals. I actually have a pull request that sort of adds this feature already, but I'm not yet entirely satisfied with it. And also, I'm considering to expose the internals for advanced applications. So why would you want to use lenses? Is that you have a data structure to manipulate. If you don't want to manipulate the data structure, then you can use something simpler. And lenses are quite simple. They're just map functions in disguise. And that makes them highly composable, and also makes them highly reasonable in that when you nest into a data structure or zoom into a data structure using lenses, then you know that the transformations work compositionally. So you can understand how lenses work very easily. And here's a link to the library. And there are other links, there are links to some other libraries and papers and resources, and you can suggest more if you like. So I'm about done.
Can you rewind?
Rewind where? Here. Okay, so do you have any questions?
Yeah, so what do you do if you need some refactoring, for example? I noticed that there are like a lot of those methods with those operations that use property names. So if you need navigate the code, like find all the lines that possess particular property, or you need to like refactor just
I'm not sure I understand. You mean that do you mean whether there's like a documentation that explains the lenses, or something that if you're manipulating data structure, then
yeah, if you're manipulating data structure and data structure has changed, or for example you want to find all the places where particular properties exist of particular data structure.
Right. Okay. So now I understand. So you have a data structure, and then you want to understand where that data structure is being manipulated, and in which ways in your code base.
Yes, basically that, and in particular with the application of these property names, because they are just magic strings.
Right. So in fact, in my applications, I often have modules that have functions and values that are lenses, and then I actually just import that module in other places and use the data structure using those. So those give the names to those operations. So I don't copy the lens definitions where I use them, but just write them once in some module and so on. Maybe a second question also. Yeah.
I was going to ask, why would I prefer to use this instead of immutable.js? And now following your links, I'm reading up your article on this. But you can probably say a little bit about why it would be a good thing.
First of all, I don't think that immutable.js would be like a competitor, because actually, does it actually provide lenses?
Well, you can kind of say like your data structure.get and then give an address to something deeply nested inside that data structure, but it's not composable.
Right.
A lot of the
So
examples you gave at least gave me the feeling that I could do the same just with immutable.js directly.
well, it's possible to some extent. I think that what you can do, for instance, is that you can actually wrap immutable.js data structures to work with partial lenses. So what you get that way is that you get a sort of a unified API for doing compositional data structure manipulation. There's actually a section on that in the documentation. And I don't know the immutable.js API that well, but like one of the things that these lenses make very easy is that you can create quite complex operations. So let's take a look at actually something more interesting.
May I answer that question also, because I have used your library. It's, for example, really easy to make a list, React list component that can take any component. Like it's very good for editors, kind of that kind of like abstract list components.
Mm-hmm. So basically, so what kind of things are probably not available in immutable.js would be, like for instance, this example that sort of explores the possibilities that you could do with lenses. Is that we have a binary search tree as a lens. So we actually create a lens that allows us to manipulate binary trees. So we can create a binary tree from pairs. So here's a sample binary tree, and then we can manipulate elements inside it, and we can also create something like the traversal of the binary tree, which allows us to get to all the leaves of the tree. So it would be interesting to know if immutable.js can help you in that regard. You can probably have a ready-made data structure in immutable.js that does that for you, but this allows you to create such operations quite easily by yourself. But I guess
we'll switch to this soon.
right.
Yeah.
But I guess I'm running out of time, so that's the end.
Thank you.
Thank you.
Would it be possible to turn on the lights for a second?
This is like how.
Can you guys see it?
What am I
What about actually that light is kind of blinding everything. Would it be possible to get the main lights on, or? Okay.
Who are we looking at?
over there? Yeah? Alright, can you guys, everyone wave hands and say hello to Turku? Hello! Alright. So, yeah, the Turku front-end meetup happened to be taking place at exactly the same time as ours, so I thought it would be kind of cool to connect us via Hangouts and just say hi to the guys. But yeah, it's nice that this year we've had Turku front-end and get started at the beginning of the year, and they've been putting on an awesome show.
For a year now.
For a year now.
So they had kind of birthday today.
Exactly. And actually, we're having our 5th birthday this month as well, 5th year birthday, or maybe 6th even. And also I should mention, since Jonas here is from Turku, but I'm actually from Tampere, I should mention that HelsinkiJS also got started this year. They've been running it for about half a year now, so it's awesome to see like JS and front-end meetups, getting going in other cities as well. And it would be really good, I think, if we could actually kind of foster more exchanges between other cities. So if you guys from Turku wanted to send some speakers our way, that would be really appreciated. And if anyone here wants to ever give a talk in Turku, then they're using Meetabit as well. So you can just go select Turku from the list of cities and submit your talk proposal directly through the site. And Juhis was saying that you guys are looking for one talk in particular on the topic of accessibility. So if anyone knows anything about accessibility, then you should definitely go to Turku as soon as possible. Do you guys want to say anything, or do you want to just wave your hands again to everyone? All right. All right. Nice. And sorry. Sing. Yeah. Do you guys want to sing for Turku?
They have their own presentation of what they want ours.
Maybe next time.
Maybe next year.
But yeah, if you guys haven't had enough of talks, actually, we're only like halfway through, or 2/3 of the way through. There's still one more talk, and it's being streamed live on YouTube. So.
Jussi, did you get it fixed?
Yes.
Great.
You're welcome to tune in for one more talk, courtesy of HelsinkiJS. All right, thanks guys.
Thanks.
See you soon.
Bye.
All right. So let's have another go. This time, at least something is running. We shall see for how long. So the subject of this talk will be about live coding. And just a second, I'll try to attach this to myself. Okay. Maybe make it a bit bigger. So it's about live coding, and in this context, about by live coding, I mean any program, any application that we are running in such a way that we are updating it on the line. So we have the program running, and then we are rerunning or re-executing some of the modules, changing the code without changing starting the application again, changing all of it, just some parts of it. And we will look at in the context of Edide, which is an editor designed specifically for live coding. And then the plan was also to look at in the context of hot module replacement in JSPM. But there's been some technical difficulties, unfortunately. So for that part, I will just need to explain it for you, and hopefully you will take it as as it is. It wouldn't have been a big demo, but a small one. I don't know, how many of you is familiar with the JS PM? Is it? Okay, some, yeah. Probably more familiar with the Webpack and React hot module replacement, but it's a similar technologies. So as a little starter, let's just take a small look in here, for example. So here we have some module. Oh, actually, maybe even before we go here, I have a couple of warnings, so maybe you already saw it. I have two bad messages for you. First is that the examples we're going to looking are going to be in CoffeeScript mostly, which is probably not your favorite language in 2016. And the second bad message is that we're going to look about the dependencies and imports, and they are not going to be in ES6 import syntax. And the reason for all of this is that this is a kind of crazy project that I started, I don't know, about 4 years ago, and I've been coding it on the side, and 4 years ago CoffeeScript was big. So just to give you a warning, but basically the things, it doesn't really matter, the things are the same, even, you know, if it's a JavaScript or CoffeeScript, they're practically the same thing. Okay, so let's look into the first example. So here we have a module, and all that this module does is it defines some strings. And it defines some colors in the hue, saturation, lightness syntax. And if you're not familiar with the CoffeeScript, all it's saying is that this dot, that et character here is basically just this. So if we're saying et purple is some string, we're saying this dot purple is some string. And this is just a teaser to show you. So if we'll take, let's say, yellow color, which is a color you probably can see somewhere here, and we change the color. So at the moment we are defining, by the way, is the font big enough? Can you see it? I can make it actually a bit bigger. Probably work fine. So we are defining the hue of the yellow, and we're defining the hue as 57, so let's say 157, and somehow everything turns to turquoise. So everything that was yellow is now turquoise. We can take some other colors, so there's a black color. Black has a lightness of 12, which is not quite that black, but it's blackish. If we change it to 19, everything goes white. And the question here is that how does it happen? We have a module that only defines strings. At the end of the module, we're not sending any events saying that this has changed. We're not saying update editor UI or anything like that. We're just changing the module, just changing some color values within the module. Actually, if we want, we can see the end result of what is this module exporting. So if we look into here, the end result of executing this module is that it exports two numbers and lots of strings. So that's just a teaser. And since I realized that this talk is quite technical, and maybe not, if you're not actually writing libraries for hot module replacement, maybe you're using React, and most of this stuff just happens for you, so in a way that you don't really even have to think about it. So maybe this is not, in the end, that interesting for all of you, so I thought that as a kind of a bit more funny example, I'll just throw in here example of what can you do in this kind of live coding editor. So here we have a kind of block world. It's a framework for creating these blockish games, and here we have a gallery with all kinds of animations that we can put inside the game. And here we kind of we are connecting the end result and the editor better to have a more nicer coding experience. So if we click here for different objects or different animations, that each of one is its own module. And then, by the way, I say we have a different module syntax, so the module syntax is here. If we have a colon in front of a string, it means that it's a module. So if I say colon rock, then I'm importing module rock inside this module. So by clicking different things, I can see the different modules within the code. And then if I want to go, let's take a flower and let's go digging deeper into the flower. And then we can see some examples of live coding. So we have all the flowers flying here, and then if we change some values in here, we can see things changing online. So let's change that. Oh wow, that's me. Yeah. And this is just give you a clue of what kind of things can be done here. And this is especially nice if you have this kind of imperative style code without much comments. You don't really know what's happening there. You can just go and mess around with it and see how the end result changes, and maybe you can try to get a better look on the code itself by looking at that. But let's get back to the program. There was just little teasers there. And actually, let's go to roll back the background. So, as I probably said before, I'm Jussi Rytkönen. By background, I've studied cognitive science, so I have a more of user experience and user interface look into programming. For the past 7 years, I worked as a coder, mostly doing front end, but also back end, so all kinds of things. And as a user experience guys, I've always been interested not only in the experience of the end users of the software that I'm making, I've also been interested in how to write code that is gives a good user experience for the coder himself. So what kind of languages, what kind of tools, what can we do to actually make better code, to be more effective, more performant in achieving the goals that we have when we do programming. And about 4 years ago, I ran into this talk by Brett Victor, Inventing on Principle, where he talks about live coding, and well, he talks about how to invent on principle, but also the examples he gives is about live coding in an editor a bit similar to examples you saw before, where he, for example, makes a game and then he jumps around in the game and then pauses it and kind of starts editing the code on the fly. And this, for me, that was kind of stopped me to realize that actually this is what I would like the programming to be. This is kind of what I felt difficult in the programming, or not difficult, but kind of stopping my creativity when I do programming. Because typically, if you're a web programmer, what you do is you have a text editor, and then you type stuff in the text editor, and then you save it, and then you jump into the browser, and then you reload it, and then you can see the results. And then you play around with the browser for a while, and then you jump again into the text editor. And you kind of have this, break between two environments that you play around with. And sure, in the browser you can open up the inspector, and you can kind of stop the code as we do in this kind of editors, and you can change the variables and play around in the inspector. But then again, when you want to make real changes, you need to go back to the editor. So you have to kind of go to the browser's inspector, look around what you want to change, and then remember what you want to change, go back to the text editor, go back to the code editor, and do those changes. So this has always felt a bit not perfect way of doing coding, and a big part of live coding is the idea of merging these two environments. So always when you are coding against live running application. So I don't remember exactly the time when I started jump on this project, but I'm guessing it was probably in the middle of the night, because that's when you get all the crazy ideas and start doing weird stuff that you'll waste lots and lots of time on. And you never know if it really results into anything. But this is what it resulted me in standing here, so I don't know. So then we get to the hard stuff. So we make a live coding editor, and we want to update the stuff on live. So you'll take some module, you want to change the state in that module. So how do you change it in such a way that you don't crash the program? So how do you change it in such a way that the state that you previously had in the application still is workable? So let's look at example here. So let's take some random dependency chart, and then we have this black module in here. The module that is in black is the one that we are editing. So if I change that module, how does it affect the rest of the application? So, well, okay, let's ask ourselves one principled question, is that why do we want to do that? Why do we want to update only some parts of the code? Why don't we refresh all of it? So we'll make some changes in the module. Why don't we just make the full reload? Well, there are two basic reasons. One is that making the full reload is slow. So think of having a really big application, maybe some game, maybe some 3D game with lots of graphics, lots of code. If you every time you make some small change, if you need to execute all of that code, it will take lots of time, seconds, a worst case even minutes. To do that, well, maybe that's not such a big problem in web development, but as we're going forward, all the front-end browser applications, they are getting bigger and bigger and bigger, and this is actually becoming a problem, especially at the time when we are transpiling the code from TypeScript or with Babel or what have you, and you need to do also the transpiling and not just executing the code. And then the second reason is that maybe there's some state in the application that we do want to retain. So if we have clicked ourselves to a specific state in the application and we want to do experiments on that specific spot, we don't want to lose the state where we are in the application at the moment to change the code. So say you have a game and you have played it at some part where you need to jump on some object, and you want to play around with the jumping mechanics and physics. You don't want to, every time you make a change, you don't want to start the level from the beginning. You want to start it from where you are actually doing the jumping on top of the block or hill or whatever. So one strategy for this is that every time you have a module that stores some state into the application, it will only do that storing inside itself. So in this example, if there is some data, whatever, that this black module does, it only stores that data within itself. So every time you recompile it or re-execute it, it will destroy the previous state and introduce the new state. And since it's never doing introducing state in the other modules, we are fine. The rest of the application is in a good shape. There is one problem though. So we have all the dependencies above the module we are modifying. So let's say the module above is referencing some data or some methods in the module that we are changing. Then if we rerun it, then the modules above will actually be still referencing the old state. So they will be referencing the old module or the old methods or the data executed within that module. So the first strategy is that every time we change the state of the module, we also need to execute all the modules that are dependent on that module. And not only that, we need to execute the modules that depend on the modules that depend on that. So in this case, if we do some changes in the black module, we need to first execute these 3 modules above it, and then we also need to execute the topmost module, because maybe the state has come flown all the way from the black module to the topmost module, and that is still referencing some old data. And this is a kind of strategy used by JSPM when it does hot module reloading. I would assume that the way it works with Webpack or React is also similar, but unfortunately I haven't played around with them that much. I played around with React previously about 2 years ago when I was able to do it in the work in a work project, and back then there wasn't hot module reloading there. And at this point I would jump to the example, but unfortunately I couldn't get the display working from my own computer, so we won't be seeing the JSPM example. But basically what it does is the same thing that I just talked about in here. There's one extra bit though. So if we introduce state from somewhere outside, so say we put something in the DOM or something in the global object, which you definitely should not do, but let's, for the sake of argument, what if you do? So in each of the modules, we can also introduce a special unloading method. So if we have a module that exports a method named basically named unload, then in that unload module we can do unloading for a state that we have kind of put outside of our module. But yeah, okay. It would be nicer to have the example. But there's also, maybe we can, if we look into the tutorial modules, I don't know, it's not the same example as JSPM Summit, but looking then. But then there's a second question. So what if we do program in such a way? So what if we only introduce the state inside the module, then what will happen? So think of an example that we have, we want to render some scene, and in the scene we want to render the background in one module, and then we want to render the items and the objects on the scene on a different module. And then both of these modules, so let's say it's a background module and then front module for the items on the scene, and both of these use a third module, which is used to create the canvas and maybe has some utility functions for modifying the graphics in the canvas. So what will end up happening if we only store the state within the modules that create the data, create the state, is that we will have the item module, the front module, including the canvas state, as well as the background module, including the canvas state. And then the canvas state is quite similar in both of them, and actually the methods for manipulating that canvas state is stored in the canvas module. But we can't put the state in the canvas module, because then if we reload, if we re-execute the first modules, the state will be left in the canvas module, and it doesn't really work. So maybe, let's say, in this example, we could have here we have this module is doing the foreground, and this is doing the background, and then we have the third module which is used to create the canvases. So we can't store the state of the canvases in the canvas module, because if we recompile either of these modules, we're going to create more state. We're going to create a new canvas, and the old canvas hasn't been removed. And what kind of ends up happening here is we end up dispersing the state. We kind of lose the traditional separation of concerns. If we have canvases, then it would be the logical place to put them in the canvas module, because that's the module that manipulates them. That's the module that has all the information on the structure of the data of those canvases. But we end up kind of dispersing the data around the application and not kind of storing them in the most logical place. So in the editor system that I've created, there's kind of there's more granular features on how to unload state from around the application, even if it's stored outside of the actual module that you are editing. So if we look into this tutorial, so here we have let's make the code a bit bigger. We're creating, basically, in the previous example I was talking about canvases, but here we have layers. So it will take a layer, we'll create a layer, which basically creates some DOM element, and at this point we're not really doing anything about it yet, but then let's put in the DOM, we'll put some P paragraph and then some text. And then the text will end up in here. So the layers is the module that controls this area in the editor. But now the layer is not only, it is in the DOM, it's not only in this module. So I will need to have some way that if I remove it, if I decide that I don't want to actually do that, I want to remove this code, then somehow magically the layer and the code, the DOM elements need to get removed from both from the DOM and possibly from some different modules where the layers are stored. And the way this happens here is that in the layers module, we have an unloading method. And the unloading method, unlike in JSPM, which can only have unloading method, but it doesn't really have, it doesn't get any parameters. It simply can be used to unload stuff that the module knows that it has introduced into the application. But here, the unload method also knows from where it is being unloaded. So, so when we have a module, it's referencing some other module, and then we break this dependency. So we change the code and we remove the dependency to this lower module, then this module gets unloaded, but we also tell it where the dependency came from. We have some ID from where we introduced the state. We can use that ID to also remove stuff that has been created from the module above. So here you see that if you create the player get, we are passing it this object, which is in practice in this syntax the module itself. And then once we have passed the module in the dependency, we can use that as an ID to remove the state from the DOM. Yeah. Maybe another example how we can be more granular about modifying the state. So if we look at here another module, and we're getting this error, and then we're going to refresh it. I introduced a nice bug in this editor just a few days ago, and I haven't been able to remove it, which just jumped again. So let's just remove it this way. So often when you're doing live coding, sometimes you will end up introducing some state into your application that you were not careful enough to remove, and then the easiest thing is to do just to reload the whole application. So sometimes you will end up removing the state that way. In this example, so in this module syntax that we have, modules are basically the this objects of this. So the module is a function, and the this object within this module is the module itself. And if we want to export some stuff from this module, we will bind it to this. But in here, every time we are recompiling the module, we are not creating new objects for the module. We are using the same old module object itself. So if we want to rerun it without changing the state in the module, so we want to be more specific that we don't want to, there's some state that we have introduced within this module that we don't want to remove, as would normally happen, then we can just say that, for example, here we have the counter. So instead of setting the counter to be some value, we will say that if the counter already exists, set it to be the counter itself. But if it doesn't exist, we will set it as 0, which is quite typical if you look at JavaScript libraries. This is often how, if you define some global state, then they will check if that variable already exists, then we don't want to override it. But if it doesn't exist, then let's initialize it with some value. And actually, if we want to do it with the coffee script, we can use a bit more terse syntax for that. But that basically does the same thing. So here we can see, I can't use this Mac. No, do it this way, right? So when we execute the module for the first time, we have running tutorial modules. So tutorial modules is the name of the module we are editing at the moment. And then every time we make some change to the code, it will be rerun again. And before it will be rerun, so here we can see it being run again, we will unload the previous state. And in the previous state, the counter is still 1, but on the next execution, the counter will start increasing. And yeah, and we can also see if we want to make a look into how this works with when we have more dependencies. So we can have a child. So if we uncomment this, we will introduce a load the module for the child, and then execute it. And we can see here that the child is being run, and then again after. So every time we depend on something new, then the child will be run first, and then the actual code itself. So we can see the order of the execution here. Yeah, I don't know. To be honest, I'm a bit offset here, so maybe I'm not sure if this is quite that clear. What's the aim here? The one example, but. Basically, the idea here, maybe let's look at one more thing here that maybe I forgot to say, is that we have, when we have the state, we have 2 different options. So we can run the code, which resets the state within this one module, but then we also have here a reload button, which will reset the code within all the children. So, like I said, the module itself doesn't get recreated every time we run it, but if for some reason I do want to remove the state from this module, and I want to remove the state from all the children, and I want to re-execute them as clean modules, then I can press the reload button. So if we have executed here for a couple of times, and we have increased the counter, we can press the reload, which will reset this module and all of its children, and the counter will start again from 1. I haven't been keeping track of the time at all, so I'm not sure how long have I gone. But maybe I'll try to go for questions and
Yeah, now's a good time for questions.
yeah. Good. So I'm just wrap up. So in the editor at the moment there's about 600 modules that I've just been hacking there myself mostly, and then about 100 of those modules are used within the editor itself uses. And as a technical side, there's backend is using MongoDB and Meteor, of which it doesn't really use that much of Meteor, but it's for technical depth it's there. Mostly it's just loading the data used for the data connection. And it supports different languages of JavaScript and TypeScript, and it has a kind of modular system for implementing the languages. Maybe at this point, if there's, I can open it for questions. There's different examples to have, but maybe for the kind of state management side of the editor, this is it. Yes.
Also, I understood this is a side project, or was. Do
Yes.
you use these at all in your normal work day?
I have used them in work. I have written both. Mostly I've used it for Angular. I kind of got this to work with Angular, so for that I've used it, and I have some examples doing it with React. But let's say in day-to-day work I don't use it that much. But I do have. I've used like there's many side projects that I have used this for.
Do you know anyone who actually uses more than you?
No, it's created by me, so I'm definitely the one who uses most of it. And maybe, I mean, this is just, in this talk I only focused on the state management, and I kind of wanted to bring in a more general view for it, for kind of compare it to how hot module replacement works in JSPM and Webpack. But unfortunately the JSPM example doesn't work, so maybe for the, this may give a little small slice of what actually is doable in this editor itself.
Thanks, Jussi.
All right. Does anyone from Cocktail say anything, or?
Okay, so there's probably beer and stuff somewhere. Please enjoy yourselves.
Yeah, we have reason to celebrate. It's HelsinkiJS turned 5 2 days ago.
Woo! Yes.
Hey guys, thanks for hosting.
And
Awesome.
also these mighty fine boxes of licorice are free for your taking. So please, there's 100 of these, so
Malta, you're here.
All right.